In this video, I'm going to derive the three main Pythagorean identities. Beginning with an angle theta in standard position, we can draw a right triangle. We can label the legs cosine theta and sine theta. Because the radius on a unit circle is length 1, we can label the hypotenuse length 1. Now let's start with the Pythagorean theorem. A squared plus b squared equals c squared, which is true of all right triangles. We can then substitute cosine theta for A and sine theta for B and 1 for C. This leads to cosine squared theta plus sine squared theta equals 1. This is our main Pythagorean identity. Using this main identity, we can divide every term by cosine squared theta to arrive at another identity. Cosine squared theta divided by cosine squared theta equals 1. Sine divided by cosine is tangent, so sine squared divided by cosine squared theta is tangent squared theta. And since 1 over cosine is secant, 1 over cosine squared theta is secant squared theta. This is the second of our three main Pythagorean identities. Returning to our main Pythagorean identity, we can next divide every term by sine squared theta. This will lead to our third Pythagorean identity. Since cosine over sine is cotangent, the first term will turn into cotangent squared theta. Sine divided by sine is 1, so sine squared divided by sine squared theta is 1. And since 1 over sine is cosecant, 1 divided by sine squared theta is cosecant squared theta. This is the third of our three main Pythagorean identities. Now let's take a look at different versions of these identities. By subtracting sine squared theta from both sides of the equation, we can derive another version of this identity. Cosine squared theta equals 1 minus sine squared theta. Similarly, another way that you will often see this identity written is by subtracting cosine squared theta from both sides of the equation. This leads to cosine squared canceling, and we will get sine squared theta equals 1 minus cosine squared theta. These are all different versions of this same identity. Now let's try a problem. Which of these three equations is correct? On the right-hand side, we have our three main Pythagorean identities. We can manipulate these three identities to see if we can come up with the equations on the left. Number 1 involves sine squared theta and cosine squared theta, so we will use the top identity. Because number 1 begins with sine squared theta, I'm going to start by subtracting cosine squared theta from both sides of this equation. This leads to sine squared theta equals 1 minus cosine squared theta. Next, we see that number 1 has a minus 1 on the left side. This gives us sine squared theta minus 1 equals negative cosine squared theta. As you can see, because of the negative sign, this does not match the equation in number 1, so number 1 is incorrect. I will use cotangent squared theta plus 1 equals cosecant squared theta to try to come up with the equation in number 2. Since equation 2 has a 1 on the left side of the equation, I will begin by subtracting cotangent squared theta from both sides of the equation. This leads to 1 equals cosecant squared theta minus cotangent squared theta. The correct identity has cosecant squared as positive and cotangent squared as negative, so number 2 is also incorrect. For number 3, we'll begin with the identity 1 plus tangent squared theta equals secant squared theta. To isolate the 1, we'll subtract tangent squared theta from both sides of the equation. This leads to 1 equals secant squared theta minus tangent squared theta. So number 3 is correct. I hope this video is helpful in understanding the Pythagorean identities.